I had built a 7-element VHF Yagi some time back. Now I am planning to build a UHF Yagi. I got a design by VU2 AAP from the October 2022 issue of QSP magazine. The basic design was of a 7-element UHF Yagi primarily meant for amateur radio satellite communication. In my region, there is no UHF repeater, with the nearest one at Bengaluru being about 277 kilometers away. So my aim of building this Yagi is to enhance my UHF reception capability during amateur radio satellite operation, which has been quite low with the current CP22E vertical antenna. Nevertheless, I was able to have a few contacts through VU satellite transponders like International Space Station, Tevel 7 and Tevel 3. When I had attempted using the VU transponder on Saudisat 1C, my VU friends told me that though they are able to hear my call, I am not hearing their replies. I found that the surplus 1-inch square boom which I had can hold an 8-element Yagi. So I marked out the locations on the boom for the elements and thought of asking VU2 AAP for the length of the 8th element. He told me that 7th and 8th elements and any more could have same length and spacing. Still, he strongly advised me to go for a 5-element Yagi initially for a broader beam width. As I was a beginner in the field of amateur radio satellite communication, my mentor felt that it will be quite difficult for me to point the antenna correctly if I go for one with more elements and a narrower beam width. He told me that leaving the remaining length of the boom like that will do no harm, leaving space for potential future expansion. In the first stage of the antenna building, I have used a hacksaw, steel measuring tape and a steel scale. A pencil was used to mark out the measurements on the boom and the 3x8-inch aluminum pipe to be cut. A few small wooden blocks in the store were used while using the hacksaw to prevent damage to the surface of the table. After cutting out the elements, a 5 cm piece of 3x8-inch aluminum pipe was cut for the gamma matching rod. Spacing between the gamma rod and the driven element was given as 1 inch. So I measured out 2.5 inch of 1 inch square aluminum pipe to be used as gamma shorting stub, which will have sufficient space on either side when holes are drilled for the driven element and gamma rod. Tomorrow I'll have to visit the nearby hardware shop to get powder coated clamps, PVC T-connector and screws needed to fix the clamps on the elements.